In this video, we will do some practice about the first and the second derivative. Look at the guided practice 1. Find the sign of the first derivative and the second derivative. Remember, the first derivative is dealing with like increasing or decreasing. For the second derivative, basically, it's dealing with the concavity. Therefore, for A, it's an increasing function. Therefore, the first derivative is a positive. Since this is a concave up graph, therefore, the second derivative is a positive 2. For second function, don't look at the arrow given on the graph. When you check it's increasing or decreasing, always from left side to the right side. See, it's from lower position to the higher position. Therefore, this is an increasing function. So the first derivative is a positive. But it's a concave down. Part of the concave down graph. Therefore, you will see the second derivative is less than 0. For C, it's decreasing from left to the right side. It's decreasing. Therefore, the first derivative less than 0. Since the graph is concave up, so the second derivative is positive. Let's go to guided practice 2. Find interval on which the first derivative is positive, which means it's an increasing function. And the first derivative is negative, means it's a decreasing function. The first derivative equal to 0, you need to find the stationary point. Which means you have a local maximum, minimum, or stationary inflection point. Let's look at the curve increasing. Let me write down the negative infinity here. Yeah, this is increasing. Here it's increasing. But you could say this 3 is a stationary inflection point. So we will write down the first derivative greater than 0 in the following intervals from negative infinity to negative 2. Union set from 1 to 3. Union set 3 to positive infinity. Here is positive infinity. For the first derivative less than 0, you could see the curve is going down. So this is from negative 2 to 1. That's the only curve decreasing. For the first derivative equal to 0, you need to figure out the maximum point. That is x equals negative 2. And here's 1. That's a local minimum. Then 3. This is a stationary inflection point. For the second derivative, it's dealing with the concavity of the curve. Therefore, when the second derivative greater than 0, that means concave up. For second derivative, it's negative. That's concave down. When second derivative equal to 0, you will find the point of inflection. Therefore, you will check concave up curve. That's from here to here. And also here, this is a concave up. We assume this point is 1.4. This point is a negative 0.4. Therefore, for the second derivative greater than 0, it will be from negative 0.4 to 1.4. Union set from 3 to infinity. For second derivative less than 0, it should be concave down. So check this graph. It's a concave down. Then this graph, it will be the concave down. Therefore, the interval will be from negative infinity here to negative 0.4. Union set from 1.4 to 3. For second derivative equal to 0, we need a point of inflection. We know at this 3, that's a stationary inflection point. And for this G and also the F, because these 2 points basically is the connection between the different concavity. So besides x equals to 3, we have negative 0.4, 1.4. For negative 0.4 and 1.4, these two are non-stationary inflection point. For 3, it is a stationary inflection point. Before we move on to the next guided practice, remember for inflection point at x equals a, make sure the second derivative equal to 0, and also there is a concavity changes at x equals a. If the concavity didn't change at x equals a, then it's not an inflection point. Also, we know when the first derivative equal to 0 and the second derivative equal to 0, this point we call stationary inflection point. When the first derivative not equal to 0, this point we call non-stationary inflection point. Therefore, for guided practice 3, we need to figure out 0, 0 is the inflection point. We already know the second derivative equal to 0. So just check whether there is a concavity changes. Say for here, this is a concave up. For this part, it's a concave down. Therefore, in this graph, the origin is the inflection point. Let's go to B. We know this curve basically is a concave up. This curve, it's still concave up. Since there is no concavity change at the origin, it's not the inflection point. Let's go to guided practice 4. We need to decide the sign at each point, the f of x, f prime of x, and f double prime of x. f of x greater than 0, which means it's above x-axis. When f of x less than 0, the graph will be, or that point will be below x-axis. When the first derivative greater than 0, that means increasing function. If it's less than 0, it's a decreasing function. Equal to 0 will be the stationary point. For second derivative, it's dealing with a concavity. Concave up means positive, concave down means negative. Equal to 0, that means inflection point. Let's check f of x. Below x-axis means negative, so AB is negative. C is on the x-axis, therefore it's 0. For D, E, F is above x-axis, so it's positive. For first derivative, for A, it's on the decreasing function, so it's negative. For B, it's an increasing function, so it's positive. For C, you could see this is a stationary inflection point, so it's 0. For this D, increasing graph, therefore it's a positive. E, it's a local maximum. It's a stationary point, therefore it's 0. F, it's on the decreasing graph, so it's negative. For second derivative, check A, definitely it's a concave up, therefore it's positive. For B, it's a concave up, because the graph will be something like this. Yeah, this stop here. Then for C, it's a concave down. But C is a stationary inflection point, therefore it's a 0. For D, you could say this is a concave down. So this is a negative. For E, it's a concave down, so it's negative. For F, it's a non-stationary inflection point. It's a 0. Because for this part, it's a concave up.